This kind of system of equations problems is another that's very common, and it's where you have to find the speed of an object moving. In this case, it's an aircraft that's flying both with the wind and against the wind. Sometimes it's a canoe that's traveling with the current and against the current, but it's a really common type of problem. This one says a personal aircraft traveling with the wind flies 520 miles in 4 hours, and on the return trip, it takes 5 hours to travel the same distance. Find the speed of the airplane if the air is still. And so the trickiest part of this, in my opinion, is defining our variables, because the variable that we want is the speed of the airplane if the air is still. So we'll call that A. Speed of the plane or airplane, I suppose, speed of airplane if the air is still. But there's a second variable that we have here that we need to know, and that is the speed of the wind. So as the airplane flies with the wind is pushing the airplane, making it go faster. And then, of course, on the way back, the wind is pushing the airplane in the opposite direction, making it go slower. So the second variable we have is the speed of the wind. Okay, now, the thing that remains constant is that the airplane is going 520 miles in both cases. So we know that when it travels with the wind means the wind is making the plane go faster. When it travels with the wind, it goes 520 miles in 4 hours. And so what we need to remember is our formula for distance, which is that it's rate multiplied by time. The speed of the plane multiplied by the time is going to tell us the distance. Well, the problem says the distance is 520 miles. We're going to do the rate multiplied by the time. So the time I know is 4 hours because the problem says so. What's the speed though? What is the speed of the airplane if it's traveling with the wind, meaning the wind is pushing the airplane faster? Now, I'm sure physicists will get mad at me for simplifying it this way, but we're going to assume that it's the speed of the airplane plus whatever the speed of the wind is. I'm sure if you ask your physics teacher, they will say that this is a gross oversimplification, that a 20-mile-an-hour wind doesn't necessarily make the plane go 20 miles an hour faster. And we'll argue about that with a physics teacher later. But for now, we're going to keep it simple. And we're just going to say if the wind's going 20 miles an hour, it's pushing the plane 20 miles an hour faster. Okay. A physics teacher can correct me later. So on the return trip, what's happening? Well, on the return trip, we're still going 520 miles, right? So the distance is still 520. But we're no longer traveling for 4 hours. The problem says now the plane is taking 5 hours to travel the same distance. And the reason it's taking longer is because although we assume the speed of the plane is staying the same, now it's going into the wind. So the wind is actually pushing the plane back, making the plane go slower. And again, we're making an assumption, which is that the wind speed hasn't changed. We're assuming the wind is blowing at the same speed both times the plane is flying. So it's going to be the speed of the plane minus whatever the speed of the wind is. Okay, so these are going to be our two equations. Now, obviously, both equations need to have the distributive property done to them. So let's go ahead and do it to our first equation. It's going to be 520 equals, and then distributing the 4 will give us 4a plus 4w. And then we'll do the distributive property with the second one as well. And that will be 520 equals 5a minus 5w. Now, typically, we try to solve our problems using the elimination method, our systems of equations problems using the elimination method if we can. And this is a set of equations that are already in standard form, meaning our constants are on one side of the equals and we've got our variables lined up on the other side. So it seems like it's pretty ripe for solving using elimination. The only problem is that the variables aren't the same, but that's an easy problem to fix. If we multiply everything in the top equation by 5, and we multiply everything in the bottom equation by 4, Oh, hey, buddy.
Is it okay if me and mommy print things?
Yes, you can print things. What do we get if we multiply everything in the top by 5? So we need to do 5 multiplied by 520, and that should be 2600, right? 2600 equals 20a plus 20w. And then we'll do the same thing on the bottom. 4 times 520 is 2080, I believe. And so that should be 20a minus 20w. And this is just set up perfectly for elimination now, where we can just add these two equations together. So let's go ahead and add them. I'm going to put the addition sign on this side. I'm going to be a weirdo and put the addition sign on the wrong side since I made my arrows too close here. But let's go ahead and add them straight down. This is 4,680 equals 40a. And of course, our W's are going to cancel out. So we have 4,680 equals 40a. So I'm going to use the division property of equality to divide by 40. And so I don't think we need a calculator for this, do we? I think we can do this with a calculator. 117. So the speed of the airplane is 117 miles an hour. That's a slow airplane. So the speed of the airplane is traveling 117 miles per hour in no wind. I'm not an airplane expert, so I don't know anything about how fast they're supposed to go, but that seems slow. Do airplanes normally travel only 117 miles an hour? I'm gonna have to look that up when I'm done with this video. 117 seems like a slow airplane. So 117 miles an hour is how fast the airplane travels in no wind at all. I don't think the problem asks us for the wind speed. It does not. The problem just wants the airplane speed, which we found 117 miles per hour is the airplane speed. If I wanted to find the wind speed, we could. We could come back up here to our two systems that we had right here, and instead of adding them, we could subtract them, and that would eliminate the A's and leave us with W. I'm not going to do it because the problem didn't ask us to, but if for some reason we wanted to find the wind speed, that's how we would do it.